Okay, so here's my actual sleep data from several nights where I collected some data with my Fitbit. I've seen this before. In the confidence interval, we saw that it was between 69 and 84 minutes of deep sleep per night, which even in the best case scenario, even if I am somehow getting 84 minutes a night, is less than the recommended 90 minutes minimum of deep sleep per night. So that information, that confidence interval, that quick little thing that we did several weeks ago tells us I'm not getting enough sleep. And that's helpful. That's helpful information to identify a problem. But what I really want to do is fix that problem. I want to somehow get beyond that so I can start sleeping better, start getting more deep sleep. And to do that, I'd really need to know what variables are related to me not getting very much deep sleep. Which variables are connected to the amount of deep sleep I get? So I've collected lots of other information that's not shown here, and even a lot shown here. I'm going to focus in, though, on one specific one, which is what time do I go to bed? Now, over here is where I recorded the actual time. So notice typically a little before midnight, or this would be right after midnight. As it turns out, this hour and minute format gets a little ugly in the correlation in the mathematics that go on. So what I did is I just converted that to the number of minutes after 10 o'clock that I started going to sleep. This is a much cleaner number to work with. And it's a variable that seems like it could have a connection. The time that I go to bed could perhaps influence or somehow be connected with the amount of deep sleep I'm getting. So how do I check that out? That's what correlation and regression and all this good stuff is. You don't need to do this. I'm just inserting some extra columns here. Running a correlation is extremely simple. It's an equal sign, correl, parentheses, and then we just select one set of data and the other set of data there, end parentheses, enter. That gives us our correlation coefficient. It's usually represented by a little r. Sometimes it's called Pearson's correlation coefficient. But it's a specific description of the connection, the degree of connection between the time I start going to sleep and the amount of deep sleep I'm getting. It'd be nice, I'm a very visual person, it'd be nice to visualize this. So what I'm going to do is select those two columns and insert a chart. It's going to correctly predict that I want a scatter plot. You could always choose that if they didn't give you that. And with this scatter plot, what I'm looking for is a trend. If there's a connection between the time I go to bed and the amount of deep sleep I get, I should see some kind of trend here in these dots. In other words, I should be able to picture this invisible line going through these dots, and that line is the key to this analysis. So if I go down, in the customize series, this trend line here is describing the relationship, is one way of describing the relationship between the time I go to bed and the amount of deep sleep I'm getting. Most importantly, for now, we can see that this line is going down instead of up. It has a negative direction instead of a positive direction or slope. And that is what we saw there. We saw that same negative, and that will always match up, by the way. This R value, the sign of that R value, and the direction of this line will always match up, even in multi-variable regression, which we'll do next week. So here, what does that negative mean? Well, it means that as I get higher and higher on this variable, in other words, as I go to sleep later and later, I'm getting lower and lower on this variable. In other words, amount of deep sleep. So the later I go to bed, the less deep sleep I tend to get. That's what that negative line is telling me, the fact that it's going downhill. Now, the next question, which I hope you should be asking, is well, how accurate is that relationship, or how strong is that relationship? And that's what the 0.34 part says. So the negative tells us a very important piece of information, that the later I go to bed, the less deep sleep I get. The 0.34 gives a sense it's starting to quantify how strong is that relationship. And certainly we can see exceptions. I mean, if I look at here, I went to bed fairly late, almost midnight, and I got a lot more deep sleep than I did on this night when I went to bed quite a bit earlier. And that tells us there's other factors involved here. And we call that noise. That makes it a little harder to see the specific relationship between these two variables. And yet, there's enough of a relationship that we do find some pattern here. So the next thing we want to do is this statistically significant? Is it practically significant? And Motulsky talks about correlation not necessarily leading into regression. I somewhat disagree on that point, because every regression has an R value at the heart of the regression, and I think no matter what, you always want to visualize that relationship between your variables. So let's go ahead and run a regression here. So if I go to add-ons, linear regression. So the Y range, Y, I like to think of it as the WHY, the variable the reason why I'm doing this whole experiment. And in my case, this would be the amount of deep sleep. I might also look at the amount of total sleep as a different regression, but for now, let me focus on the amount of deep sleep. So all I do is highlight that data and click in here. My X is my predictor, which is the time I'm going to bed. Click in there. I did, when I selected those entire columns, and by the way, I shouldn't have any numbers down here, which is why I deleted them off before I did this. I did include that column header. When I clicked that entire column, that included the column header as part of my Y range, and same for my X. So I do want to check that labels box. If I would have only selected the data like this, then I would not have checked my labels box. The output range is the next thing we need. Let's go ahead and just throw that over here. And I'm going to click there, run the regression. Okay, non-numeric. So if you do get this data, that's telling me that something in columns U or E is throwing us off. The best way to fix this, I think, is just go ahead and select the actual data. So I had selected the entire column. Now I'm just going to click, hold down Shift, click on the top. This will allow me to just select the data that I'm actually looking for, and we'll give this another shot. And that should work. So we get our output. So what do we do with all of this? Well, first of all, notice that this number matches up exactly with this, which again is the correlation coming through into the regression. The very first thing, or one of the first things you would look at in a regression is there correlation between. But we want to know, is that a statistically significant correlation? How do we tell? Can we just gauge it by how big that number is? As it turns out, we can't. That's going to depend on a few other factors, the standard error, things like this. So we go down here to this significance F. This number right here, it's in the ANOVA section on the far right, significance F. There, so you can see the word significance F. This is essentially a p-value. In fact, it's so closely related to a p-value that if we look at the p-value for this variable we were testing, we're going to see the exact same number. When we throw in more variables into our regression, this won't match up with everyone. But when you just have a single predictor variable in your regression, we will see the exact same number on these two. So it's a p-value. We know how to interpret p-values. The lower the p-value, the more evidence against the null hypothesis. But what's the null hypothesis in this case? Remember, null means nothing. So in this case, there would be no relationship between my deep sleep and the time that I go to bed. Those two have absolutely no connection with each other whatsoever. That's my null hypothesis. The lower this number is, the more evidence I have against that null hypothesis. And as you can see here, I would not have a statistically significant result. I'm not below 0.05. However, in my particular case, because I care about this is data I collected, I do want to go a little deeper and see what I may have found, especially because my sample size wasn't real big, and that, as we know, is highly connected with p-values. So what I want to do here is go a little further and just see what the results actually tell me. Next thing I want to do after looking at statistical significance would be practical significance. And here's where we look at our r-squared. So we have three values here to talk about. This one is the correlation coefficient, r. Notice there is a sign difference there. And the reason why that is, this multiple r, and I might even just put this as a lowercase r, because that's how you'll see it described throughout the week. It never has the sign on it. It's always shown as a positive number. To get the sign, you really need to look at this trend line, which direction the trend line is going. And in this case, it was a negative trend line. So that's why I would say that my R is negative 0.348, not positive 0.348. So you always need to look at the direction of the trend line in order to know what sign your correlation coefficient is. If I were to square that, and let me go ahead and do that, equals, I'm going to take this number, multiply it by itself. I should get the next value in the chart, which is r-squared. It literally means you're taking the r, multiplying it by itself. You're squaring it. This number can be changed into a percent. If I put this as a percent here, this number cannot. I mean, you can select percent here and it'll convert it to a percent, but you should not do that. I'm going to undo that. It won't be a meaningful percent. This r-squared is a meaningful percent. This is an effect size, and what this effect size is telling us is that 12% of the variation in my deep sleep, so there could be all these different things influencing my deep sleep, but 12% of these differences that I'm getting night by night are somehow connected to the time I go to bed. Doesn't necessarily mean cause. This is still at a correlational level to say that it's connected to, it's explained by, it's associated with. However, we can say that 12% of this deep sleep is somehow tied to the time I go to bed. For me, that is a meaningful effect size. Clinical significance, practical significance, all depends on what you're studying, what you care about. To me, that's something that's a meaningful output. Now here's an adjusted r-squared too. What's the difference between this? This could also be a percent. If I want to, I can convert that to a percent, a meaningful percent. It means the exact same thing as the r-squared value. The difference is this here is the actual value for these 24 nights of sleep. This is based on the data given. It's the best prediction for the connection in the population. In my case, the population would be all nights of my sleep, not just the 24 shown here. So I tend to go for the adjusted r-squared, although the higher your sample size, the more these two will be connected, the more of a precise reading you'll get on this adjusted r-squared. So this is a measure of this is statistical significance. This is my practical or clinical significance. And in the next video, I'll show you how to look with the regression line.